Hello and welcome everyone. This is Mohammed Inzamam from SAIMEDHA Coaching Center, Koti, Hyderabad. As promised, every day oka video, free content, SAIMEDHA Koti, Hyderabad, the YouTube channel lo update avvabotundi. This is the second video. Video 1 inka watch cheyaledante kachithanga adi kuda video watch cheyandi. Okay. In this video, we are going to be providing the free content for AE-AEE civil aspirants koraku. Subject is fluid mechanics, chapter 1, fluid properties. This is the video lecture 2. So ee video lo manam cheptukunedi topics emunnayante fluid mechanics, continuum mechanics, nuts and number, mean free path, characteristic length, a basic regarding the properties, fluid and its deformation. So these are the topics guys that we are going to cover in this very video. Video ni full ga watch cheyandi. At the end of the video guys, I'm having a exciting news for all the AE-AEE aspirants. And one more time, those who have not subscribed this channel guys, kachithanga is channel ni subscribe cheyandi. Prati okka roju free educational content we are going to be updating in this very YouTube channel. Press the bell icon to be notified for the every update from SAIMEDHA Hyderabad and join the Telegram channel. Let's get started now. The topic now. Here now we need to discuss about the definition of fluid mechanics. What does an actual fluid mechanics look like? Fluid mechanics is a branch of continuum mechanics. Usually in some textbooks you will be finding the basic definition also. Fluid mechanics is a science which deals with the behavior of fluid. It can be under the state of rest or it can be stayed in the state of motion. Fluid under the rest is called as fluid statics, fluid under motion is called as fluid dynamics, fluid under motion with consideration of force is fluid dynamics or fluid kinetics, fluid under motion without considering the forces is fluid kinematics, okay, that we basically know. And if you want, I will write the definition also, that is in short form itself. Fluid mechanics is a science, fluid mechanics is the science which deals with behavior of fluids, under rest or motion, Fluid under rest is called as fluid statics, fluid under motion with force, fluid dynamics or kinetics. Here dynamics and kinetics both are same. Engineering mechanics, dynamics is main science, kinetics you will be having subdivisions, but here fluid dynamics and fluid kinetics will be same, one science. Motion without consideration of force, considering forces, these are called as fluid kinematics. These are the basic definitions that we will find in the textbooks, okay. Just for the sake of understanding I have written it here, but for now what is the main actual definition that we are gonna bother about, where we can see the question in the Public Service Commission, GATE and ESC. From this part of definition of fluid mechanics, question is gonna appear, okay. So fluid mechanics is a branch of, this is what we need to focus here, this is an important one. Fluid mechanics is a branch of continuum mechanics. Fluid mechanics is a branch of which mechanics? Continuum mechanics. What is the meaning of this continuum? Continuum indicates without any voids, without any gaps, without any air pockets, okay. So here we can write it as like this. Let's discuss in detail about here continuum. So what we can write, the idea of visualizing the matter, as a continuous, homogeneous without any voids, gaps, air pockets. If solid is there, then we need to talk about cracks also, okay, but here we are talking about fluids, so air pockets, substance is known as continuum. Whereas continuum implies that there is no vacuum in the fluid. There is no vacuum in the fluid. The validity of continuum is based on a, whether you are saying, sir, the matter is continuous or not, you need to define based on some logical statistics. Okay, some statistics must be there, some numerical values must be there, based on which we can say a material can be regarded as a continuous material or not. If you see a solid, liquid and a gas, solids will be having molecules very closely packed, liquid molecules will be loosely packed, and gaseous molecules will be having some large distances in between the molecules. Okay, so based on the comparison between the solid, fluid and gas, we can say that solid is a continuous matter, but in general solid is also not a continuous matter, because in between the molecules you will be having some cracks, you will be having some edges dislocations, you will be having some boundary dislocations inside the solid bodies also. So what are we going to take? We are going to take some assumptions based on which we are going to think that yes, this body if having very least gaps, so yes, it can be regarded as a continuous matter. So okay, sir, what is that least gap now? What is that value? What is the statistical number based upon which we can say that if beyond this value gap is there, it is okay, it is non-continuous matter. If up to this limit gaps are there in between the molecule, that can be regarded as a continuous matter. So that number which is going to be giving us an indication whether the matter to be regarded as continuous or not, that number is called as non-dimensional number, Knudsen number. The validity of the continuum is based on that number only. What is that number? Try to memorize the name, very important. This number is called as Knudsen number. Okay, this number is called as what? A Knudsen number. Go through it one more time. What is the fluid mechanics branch? Fluid mechanics is actually a branch of which mechanics? Continuum mechanics. What is the meaning of continuum? Continuum states that a body, a substance will be regarded as a continuum whenever it is not having some voids, gap, free of vacuum, free of any cracks, free of dislocations. Okay, and it is a homogeneous material, continuous material. Homogeneous, homo means same, genus means origin, same originated material is there. Okay, focus on this number now, because this is the number which is going to be acting as a condition whether the substance can be regarded as a continuous material or not, continuous matter or not. So what is this Knudsen number? Knudsen number says, Knudsen number is defined as mean free path or free length, mean free path or free length divided by characteristic length. Mean free path or free length divided by characteristic length. Okay, go through it, try to memorize the formula. So what is a Knudsen number? Knudsen number formula is mean free path or free length divided by characteristic length. Sir, what is this mean free path? This mean free path or free length is regarded as the average statistical distance traveled by a fluid particle or fluid molecule, you can say fluid molecule to strike another molecule, or distance between two consecutive collisions. This is molecule 1, this is molecule 2, this is travel distance here. So consecutive distance between two collisions. Okay, that can be regarded as mean free paths, or distance between the molecules, or you can say some gap between the molecules also. Okay, go through it once. Consecutive distance between the two collisions, distance traveled by fluid molecule to strike another molecule, or distance traveled by one molecule to coming in contact with the another molecule. That distance is called as what? Mean free path or free length, denoted with lambda. Characteristic length. Characteristic length is a physical dimension, you can say as channel width or hydraulic diameter, can be regarded as this characteristic length. Characteristic length. What is the meaning of characteristic length? It can be regarded as channel width, usually when we are going to talk about some channels, but here it's going to be talking about the diameter, hydraulic diameter. Okay, characteristic length, the primary dimension, the primary length parameter in the given flow problem. In the given flow problem is known as characteristic length. So, sir, everything is okay, but what is the number which is going to be telling us whether it is within the range or whether it is out of the range, whether it is within the assumption of continuum mechanics or not? A continuum mechanics will holds good when the non-dimensional number Knudsen number value is lesser than equal to 0.01. This is the number that we need to focus upon. Okay, what is the number value we are going to memorize here? Knudsen number is lesser than or equal to 0.01. Under this concept only, concept of continuum holds good. If Knudsen number is lesser than equal to 0.01, under that condition what happens? Concept of continuum holds good. Concept of continuum holds good. Go through it now. Okay, try to memorize. Continuum is going to be valid under this condition only. Okay, if Knudsen number is greater than 0.01, then it is rarefied gas flow theory. Okay, if Knudsen number is greater than 0.01, then it is gas flow theories. Rarefied gas flow theories. Okay, gases are basically studied in terms of another theory that is called as molecular theory of gases. What is it called as? Molecular theory of gases, because gases will be having huge amount of distance in between them. If you see the comparison in between the liquid molecules to the gaseous molecules, gas molecules are very far away from each other. Solid will be closely packed, liquid will be loosely packed, gas molecules are very far away from each other. That's why gases cannot be studied based on concept of continuum. Okay, go through it once, try to memorize. What is the concept of continuum? Let's see over the board. Fluid mechanics is a branch of which mechanics? Continuum mechanics. Continuum states that a substance need to be a homogeneous material, continuous material, without any vacuum, without any gap, without any air pockets, without any voids. In short, the molecules are perfectly packed in a given volume. But do the molecules are perfectly packed in the given volume? Liquid molecule does have gap in between them or not? Yes. How much gap is permitted? How much gap is not valid in the concept of continuum is given by a non-dimensional number called as Knudsen number. And what is the formula for the Knudsen number we have? Knudsen number is equal to characteristic length, mean free path or free length divided by characteristic length. This mean free path or free length is the distance travelled by one molecule to strike to another molecule, divided by characteristic length, that is the hydraulic diameter of the molecule itself. So if you see the comparison between the gap to that of the molecular size is going to give you a number value 0.01. That is 1 by 100th. That is 1 by 100. If the Knudsen number value is less than or equal to 1 by 100, then only then concept of continuum holds good, or else it is going to be studied in gases, that is molecular theory of gases. Okay, go through it. Chalo, pause the video and note it down. I'll go for the previous slide so that this slide also you can copy down. And now we have the next slide for the Knudsen number. Okay, go through it. So now we can say that concept of continuum is valid throughout the syllabus of fluid mechanics. You can write it as a note point that concept of continuum is valid throughout the syllabus of fluid mechanics. Okay, in our study, in the syllabus of GATE, Engineering Services and Public Service Commission, throughout the study we will be taking fluid mechanics as a continuum mechanics only. Okay, in masters, when you are going to do for some turbo machinery, some fluid mechanics, they will be having different sciences in the fluid also. They will be assuming molecular theory of the gases, rarefied gases, nano gases are there, nano materials also when we talk about, then gaps will be taken into account in detail studies when we are going to talk about micro channels and the fluid flow. There we cannot apply the concept of continuum. Okay, there we need to go for molecular theory sometimes, there we need to talk about the gases, different type of gaps will be there in between the molecules. Based on that, the study is totally different. But in our syllabus of ESE, GATE and PSUs, we will be discussing the entire syllabus of fluid mechanics in the concept of continuum only. Okay, go through it once. So now let's discuss in detail about what is a fluid, and when a flow is going to happen, what is it called as no slip condition. What is the meaning of this no slip condition? No slip condition. If you observe a pipe flow, okay, let's say pipe in which some flow is happening in here, which is giving a velocity profile parabolic. What is the velocity profile? Parabolic. Okay, generally real type of fluid flow, where we can say this is laminar flow, viscous flow. We can say this one as which flow? Laminar flow. Viscous flow is happening. Resistant flow, oil flow, grease flow, retarding flow, decelerating flow, all are comes under viscous flow. Here at this particular point, let's say this is the point A and here this is the point B. So we can say that velocity at a particle A is equals to 0, velocity at the B particle is also equals to 0. Whereas when a fluid is going to be moving, okay, over a particular plate, let's say this plate is fixed and this plate is under motion, then we can say that this plate is having some velocity here, and then this is the point A. Let's say this is point A, this point is B, where velocity at a point A is equal to 0, velocity at the point B is not equal to 0. Some relative motion is there in between these two plates. Suppose two bodies which is having some linear motion also. Linear motion. This point, let's say it is A, this point, let's say it is B. Okay. Here we can say that velocity at A is equals to 0, but velocity at the B is not equal to 0. So velocity at B is equals to, let's represent with what? U here. Velocity at B represented by some U. Some difference in velocities is there in between the two parallel planes. This flow is regarded as which flow? Couch flow. This flow is regarded as which flow? Couch flow. This flow is regarded as a couch flow, where velocity at particular point is 0 and another point velocity is existing. So here, what is it regarding the slip conditions or no slip condition? Are we talking about this point A, this point A, here the point A and a point B? You can understand it much better when I give you one more example, that is a pile of books. Suppose this is a pile of books, and applying the force over the topmost layer, then you can see here the bottommost book is not even changing its position, but the four other books which are placed above is changing. So this point, let's say this point is A, is here the velocity at a point A is equals to 0. This condition is called as what? No slip condition. Okay, no slip condition. When a real fluid, when a real fluid under flow past a solid boundary past a solid boundary, the fluid particles adjacent to the surface stick to it such that there is no relative motion between them. This is known as no slip condition. Okay, go through it. Now we know about the no slip condition also, based on which the questions can be appear. In short, what is the no slip condition, sir? Sir, you are discussing about some laminar flow, Coulter flow, difference in the velocities, pile of books. In all these examples, the common thing is velocity at a particular point is becoming zero. That is, influence of force is becoming zero. Why? Due to some resistance is happening. See, in the first diagram, we can say some frictional resistance are there. The fluid layer is coming in contact with the pipe. Okay, in between that pipe to that fluid, some ridges and grooves will be there, surface roughness, where the oil is going to be getting stagnated, and velocity of the particle in that stagnated layer, in that film, is going to become zero. Okay, so velocity of the profile, as it is coming away from the boundary, we can see the velocity is increasing in a parabolic manner, and then while it is coming closer to the boundary, its velocity is again becoming zero. So wherever the velocity is becoming zero over some adjacent layer, where influence of frictional force is more, inertia is more, resistance is more, due to that reason velocity is becoming zero. That condition where velocity of the particle is going to become zero is called as no slip condition. Here you can say pile of books over which I am applying the topmost book, some force getting applied. Then first book is moving, second book is also moving due to some adhesive motion is there in between these two bodies. So second one book also move, third also move, fourth also move. So you can say cohesion also, or adhesion, some contact of attraction is there in between these books. At last, but the bottommost book is not even moving by a mm or micron. Why? Because of the influence of books, influence of the force is getting nullified, and that too at the bottom of the book you are having the maximum resistance due to weight, inertia, some surface roughness, okay, some bottom friction is there due to so and so reasons, and resistance, the bottommost book is not even moving by an inch. So the bottommost book is the point from where it is not even moving a little bit also, that condition is called as no slip condition. Let us apply this to a fluid layer also, with which we can understand it much better. First of all, you can pause the video and note it down, or else we see this example now. Suppose here in the fluid I am applying the tangential forces over the topmost layer. This particle is going to be moving. Okay, this particle is going to be moving. So here another particle is also going to move, another particle is also going to move. So infinite layers are going to be moving, but here you can see the velocity profile is reducing. Why? Because of the influence of the force, as it is going deeper and deeper due to the resistance of the fluid, that is viscosity, is gonna drop down. What we apply is some tangential force. What is the inertia inside the fluid? Viscosity. So the viscosity is going to be resisting that applied force, and we can say yes, the force influence is decreasing. At last, this is the point after which there is no layer which is going to move due to the influence of this particular force. Okay, the force is going to get exhausted. Force exhausted after few layers. After subjecting few layers in motion. After subjecting few layers in motion. A point where applied force is totally exhausted, totally exhausted, as given in figure. That point is no slip condition. Okay, see here, an application of the force is getting nullified up to a particular point. So here we can say this is the point where it is regarded as no slip condition. Okay, go through it, try to memorize this one also. I'm going to the previous slide, pause the video and note it down. First of all, regarding the no slip condition, okay, then go through this slide now, where we can easily understand what is the meaning of the no slip condition. Force is getting exhausted when we apply, due to which layers? Due to the resistance of water, viscous forces. Here you will be having the viscous forces. So viscous force is there, resistance is there, force when we apply in the forward direction, some reverse direction, some backward direction, some resistance force is there. Eventually this force is going to exhaust after a particular period of time, period of layers. So once the force is totally getting exhausted, at certain point there is no influence of force now, that point is regarded as no slip condition. Okay, go through it, try to memorize. Now in the next section that we need to talk about is properties of fluids. In the properties of fluid also we are having some specific properties. Let's see, over which our area of interest should be more, because engineering services gate examination PSUs have already completed the video lectures of previous examination questions, gate previous PYQs, ESC PYQs, and what you can call it as Public Service Commission, TSPSC, SSC JE, that all questions are updated in the app itself. So what I have found that in my experience, from where the questions are maximum appearing, okay, that specific properties we need to focus. Okay, properties, we can say here basic properties are there, okay, all other properties, and now some specific properties where we need to keep our area of interest. The specific properties are, first and the foremost important one, viscosity, then we have surface tension, then we have vapor pressure and cavitation concept, both are interrelated to each other. So vapor pressure I am gonna write, so cavitation also you need to think. And the next one is viscosity related diagram, that is rheological diagram. One diagram is there, rheological diagram, there we need to talk about different types of viscosities. And compressibility bulk modulus also is important, compressibility. Okay, you can see these are the specific areas, actually 4 only. Compressibility is not much area of interest now, but for now viscosity, surface tension, vapor pressure. In turn viscosity also we are having a separate topic that is called as rheological diagram, where we are going to discuss about Newtonian fluid, non-Newtonian, dilated, pseudoplastic, thixotropic, rheotropic, and many more examples and equations are there in the rheological diagram that we are going to see as an important concept. Okay, go through it once. Chalo, pause the video and note it down. In the basic property section, we will be talking about mass, specific mass, volume, specific volume, weight, specific gravity, okay, and many more areas are there, volumes are there. We are going to discuss in the basic property section. Chalo, go through it, pause the video and note it down. Congratulations everyone, you have made it so far. This video watch chesarante kachithanga mee knowledge lo some points definitely could have been added. So my dear students, sir, what is that news? SAIMEDHA Hyderabad is launching new course for AE-AEE in the app Space Gate and conducting a SST Space Scholarship Test and providing 100 up to 100% scholarships, guys. Those who are going to be securing much well marks, definitely వాళ్ళకి 100% scholarship వస్తుంది. Minimum ఎవరైతే attempt చేస్తారు examination and scoring minimum marks, guys, starting percentage of concessions are 85%, 87%, 89%, 90%, 91%, 100% వరకు full scholarships అనేది మీకు ఇవ్వడం జరుగుతుంది. సార్ టాలెంట్ టెస్ట్ ఎగ్జామినేషన్ కి సిలబస్ ఏముంది? ఇదే సబ్జెక్ట్ ఫ్లూయిడ్ ప్రాపర్టీస్, ఫ్లూయిడ్ మెకానిక్స్ నుంచి మీరు టాలెంట్ టెస్ట్ ఎగ్జామ్ రాయబోతున్నారు. సార్ వేర్ ఇస్ ద ఎగ్జామినేషన్? SAIMEDHA హైదరాబాద్ ప్రెమిసెస్. వెన్ ఇస్ ద ఎగ్జామినేషన్? 11th February 2024. ఇదే మంత్ మార్నింగ్ 10 o'clock to 10:30 examination is going to be completed, followed by a guidance program, and definitely guys you are going to understand this program, what is the importance, everything is going to be explained there. So my dear students, what are you waiting for? Join our Telegram channel. I'll provide the link in the description, and download the app Space Gate. Prepare well for your examination and don't miss this opportunity. Endukante 100% scholarships already batch 1 అయిపోయింది. This is the batch 2 we are starting. And my dear students, subscribe the channel, press the bell icon, join the Telegram channel with one more video. I'll come back tomorrow evening. Thank you very much. This is Mohammad Inzamam signing off.